Good morning, everyone in the audience. Good morning. Waiting just half a minute for people to join, and then we will get going without any delays. Okay, then I say we get going, and I'm sure there will be a lot of people joining in the next minutes. So in any case, we don't want to waste any time and want to welcome all of you to our, let's say, breakfast webinar on the topic of industrial-urban symbiosis and the lessons from our EcoSites in the SYMSITES project. I'm sure you're wondering, you, the audience, what the EcoSites are, also what the SYMSITES project is, and maybe even what industrial-urban symbiosis is. But no worries, we will explain all of that throughout the webinar. My name is Felix Schumacher. I will be moderating today, taking you through the webinar, and yeah, very happy to have all of you here. Before we jump into the interesting part, so all the presentations, all the inputs from our expert speakers, we have to do the boring part, which is the housekeeping. So if you can, it would be great if you change your name. Also to keep your microphone muted, even though I don't think you can even turn it on. And yeah, of course, for any questions, you can use the Q&A function that Teams offers. We will also record, or we are already recording the webinar, so this is taken care of. So we will share the link afterwards, upload the video to YouTube, and also share the slides and the materials we are using throughout the webinar with all of you afterwards to take another look if something is interesting. Looking at the agenda, so we have a very packed agenda, 1.5 hours, so lots to talk about. So first we will set the scene a bit. We will learn about industrial-urban symbiosis, a bit about the concept we are dealing and operating with here. And then you will hear from Emma Perez, who's the project coordinator of the SYMSITES project, about the SYMSITES project itself, what it is, what these EcoSites that are at the center of the projects are, before then diving deeper, hearing presentations from all 4 EcoSites from 4 different countries all over Europe, with these very interesting case studies we have here. And in the end, we will also jump into a quick panel discussion. So yeah, if we manage, if we have some time, we can also take some questions from the chat there. But in any case, our speakers can also reply directly to you in the chat with any questions you may have. Today, taking you through this webinar, that's me, Felix Schumacher, together with my colleagues Nikolai, Chiara, and Jon. We all work for ECLAIR-Europe. We are a network of local governments all over Europe, working on sustainable transformation in the cities of Europe. So if you have any questions, anything that doesn't work, technical issues or something like that, we are very happy to help you. Just put a message in the chat. And one of us will be able to support you. So without further ado, I want to hand over to my colleague Nikolai. Nikolai is a senior expert on circular economy here at ECLAIR-Europe. He manages circular economy projects and also develops them, and he's a liaison with the European Body for Standardization on behalf of the SYMSITES project, and he will explain the concept of industrial-urban symbiosis and more. Over to you, Nikolai.
Thanks, Felix. Just sharing my screen with you. Yeah, I'm going to, thanks for the introduction, Felix. I have a slight cold, but I hope I manage. I'm going to just yeah, try to set the scene a little bit for you.
I think it's the wrong slide deck, Nikolai.
Ah, okay. Which one is it? This one, simply.
Yeah.
Yeah, just to introduce the topic a little bit to you when it comes to industrial symbiosis. And I suppose you guys are all aware of this as well. We see this as a city network, and we feel this, see and hear this in Horizon projects, that the concept is gaining momentum, not the least to speak of the Circular Economy Act that is upcoming end of this year, but also the Clean Industrial Act. But the concept itself of industry symbiosis without the urban component is really not a new concept. We know of, for example, the famous Kalundborg site that has been developing these types of relationships, of symbiotic material relationships, since the 70s and potentially earlier. We know of examples, for instance, in Sweden, where IS or IUS is being utilized in Helsingborg really as a vehicle for climate mitigation efforts, which is another big topic, obviously, which is enshrined into IUS. But we also know of examples where the collaboration itself is in the center, where you have many different, very different industries and industry types collaborating that are focusing on saving virgin material production inputs, but also avoiding waste. And the concept is also not Europe-centric in that sense. So this is just an example of Ulsan City in Korea, where there are several very large industry parks being linked together to exchange heat. And actually in Asia, there are a number of examples, with a lot of good examples we know of in China, for instance. So a very, very broad concept that is focusing originally on the exchange of waste and byproducts, residues, and energy, water, materials, excess heat, etc., but being focused on the cross-company collaboration with the aim to reduce wastes and, of course, save costs. Wastes also translating to costs, obviously, for many companies, but also to save virgin production inputs. And when the sort of urban aspect is being added, which is always, especially when it comes to experts in the standardization field, where I'm coming to in a second, always a bit debatable what do we mean by industrial symbiosis and industrial urban symbiosis. But essentially, the urban component is really adding urban material flows as a feedstock to these types of symbiotic relationships, where you have wastes, urban wastes, obviously, energy, water, wastewater, etc., coming from urban systems, including also urban production systems, for instance, agricultural systems, and linking them to different industries that are then utilizing with the same principle as with the industrial symbiosis. But with this addition, obviously, the whole situation, not only the material exchange and the symbiotic relationship becomes more complex, but also the stakeholder landscape becomes more complex, and you have different types of actors that you need to deal with: local authorities, their waste utilities, urban producers, etc., which requires obviously a different type of facilitation and a different type of coordination. And why does this matter to cities and regions? Obviously, cities and regions are focusing or are hoping to help boost their circular economy and resource efficiency targets, reduce emissions, etc., but also create local economic opportunities, as well as strengthen energy security, resilience, etc. When cities are then, in recognizing some of these gains, obviously there is a distinct role for local authorities to play. And obviously, for ICLE as a city network, we are very keen on strengthening cities and regions in taking up these active roles. For instance, whenever you have strong iOS components within the strategic sustainability agendas in cities and regions, for instance, circular economy action plans and these types of things, smart specialization strategies. You have an active local authority which is able to mobilize also the different actors in this sphere, and really take up a sort of a driving seat, or be in a driver's seat, also facilitating and sort of moderating the build up of such a project. Actually, connect stakeholders, provide data on flows, etc., which is a decision support that can help also industries navigate through such a development project. But cities can also, or local authorities can also then promote iOS, raise awareness, try to convince the public, talk to universities, etc., but be a little bit the interface within such a development. And lastly, obviously, the incentivization and the monetary aspect, but also simply financing or taking part in the financing of such a project. I talked about the benefits. I think these are clear, and we see those also very much being recognized when working with cities and regions and industries in different European projects, in the CCRI and across the board. But maybe to emphasize again the place that the concept is really taking up in, or can take up, the potential it has to take up in cities' climate mitigation efforts. When you think about the EU climate mission, for example, we have 112 cities, or maybe more even, currently on the path to climate neutrality, with very distinct action plans, with investment plans that are actually matching these actions, or are aiming to match these actions with private investments. And a lot of these plans are containing circular economy actions, and some of those actions are really addressing industrial-urban symbiosis. So the topic is hot, to say very bluntly, and I think that needs to be. Okay, now I'm sorry, I'm being confused why this is repeating. And this is matching also the role it's really taking within the circularity transition. We have a lot of actions being taken on very different areas, be it in the construction side, which is a very, very important, maybe the important topic for circularity at the moment, which is a little bit distinct from the conversation that waste handlers, utility companies, etc., are having, because it deals with a totally different set of actions, materials, sectors, etc. But from a local authorities perspective, and also what ICLE is trying to promote, is that all of these actions, be it on prolonging buildings and cars and other long living goods, using them more intensively, etc., all the way to building symbiotic relationships when it comes to waste. These are all part of a set of actions that cities and regions are promoting and need to promote in order to advance on this circularity transition. And iOS takes up, I think, quite an important role in this. And at the European level, I think you are aware this is being recognized as well. We have the Circular Economy Action Plan reflecting this. We have most of the EU innovation programs addressing this, Horizon, Life, all the ones. We have the CCRI that has a dedicated working group on iOS, which will continue presumably for the next 2 years cycle to be seen. And also we have a couple of very important issues that I think most of you are more aware than we are, if you come from a utility company or from a city, the types of demands and regulatory needs that still need to be addressed. And we hope that some of this is being addressed in the new Circular Economy Act that we can expect towards the end of this year, but remains to be seen. And in terms of standardization, I addressed it also a little bit already. which is of course a very important and also active arena. We see that there's quite a gap, especially when it comes to definition of terminology, of data, of defining sort of the interfaces between different actors operating in the iOS space, and standards presumably on this operative side can really fill this gap and need to fill this gap. And there are currently quite some sort of some movement and some undertakings going in this direction. We have a standard on iOS being developed within the SEN Committee 465 on sustainable cities and towns, which is underway, where actually the SYMSITES project is also a liaison observer to it, which is based on a workshop agreement, or on a SEN workshop agreement, so-called, that has been developed in 2018. Maybe some of you have been involved or know about it as well, which is the basis for that, and is hopefully setting some of these definition, or filling some of these definition gaps, and providing sort of a common language and also a common perspective into how to advance the topic in the future. The same, and maybe even more, is notably the RISERS project, which is developing a standardization roadmap, actually, which is hopefully also forming the basis to advance the topic in Europe and beyond. And just summarizing with a couple of or ending with a couple of issues that we see also when in working with some of our EcoSites and in the project, is that we really have a fragmented governance and regulatory landscape with often unclear roles, overlapping mandates, which require each time quite a unique approach to building an iOS project, because you need to define and negotiate these roles every time quite specifically, without having like a blueprint that can be attached simply to any project. We have, of course, the lack of harmonized standards and legal certainty. I mentioned this already. Clearly, the financial and the business model side is something which is also needs to be assessed and negotiated each time, and is often not clear, operating with unclear margins, etc. The interoperability I spoke about as well, and I think we're going to hear about this later as well. And lastly, the skill gap and limited social acceptance, and also a complex stakeholder landscape, which I mentioned as well, which is needs increasing effort by those involved. And again, cities and regions can play an important role there by managing and balancing and moderating these types of interests from different groups. But with this, let's say some issue overview, I want to turn it over back to Felix and to Emma Perez, who is the coordinator of the SYMSITES project, who is going to dive a little deeper, I think, into the project and the EcoSites, the demonstration activities that we implemented. Thanks.
Great. Thanks a lot, Nikolai. We already see an interesting discussion also kicking off in the chat, so that's great. Anyone who wants to jump in there, please feel free to do so. And with that, I can introduce, we have now mentioned several times, Emma Perez, the project manager of the SYMSITES project. She works for ITEX, coordinating partner of the project. She has a PhD in chemistry, specializing in water and wastewater treatment technologies, and brings over a decade of research and applied experience in analytical chemistry and environmental processes. Over to you, Emma. You are muted.
Sorry for that. So thanks a lot for your presentation. I'm going to share my screen. You can see it, right?
Yes.
Yes.
Okay, perfect. So I'm going to present the SYMSITES project. I would like to start by highlighting a challenge that we are all facing. The amount of wastewater and solid biowaste we produce keeps growing as population rise and cities expand. This leads not only to a water pollution, but also to an overuse of natural resources. Because of this, we need to rethink how to deal with waste. instead of seeing it as something to dispose of, we are shifting toward a much more meaningful idea, waste as a resource. This approach fits perfectly with the concept of industrial-urban symbiosis, which encourages long-term collaboration between different actors as municipalities, citizens, and industries to get more value out of resources that usually go unused. Doing so, we improve the competitiveness, we reduce emissions and dependence of fossil resources. Even we strengthen the local development. And the solution explored by the SYMSITES project contribute directly to this idea by turning waste and byproducts into new and eco-friendly resources. The SYMSITES project is part of the European Twin Transition Goal, and its main objective is to develop technologies and solutions that support the industrial-urban symbiosis. In simple terms, the project aims to help citizens, municipalities, and industries, as I said before, work together so that wastewater and waste materials can be managed more sustainably and used more efficiently. To make this a reality, the project has established 4 ecosites in 4 European countries. These ecosites can act as real-world demonstration hubs. Each one represents a different industrial sector, geographical context, and socioeconomic environment, allowing the project to test and showcase its technologies in different settings. As you can see, one of the ecosites is in Denmark and is based on the brewery industry. Another one is located in Austria, based on the meat industry. The third one is located in Spain, based on the textile and cosmetic industry. And finally, but not least, the Greek ecosite is based on the olive refinery industry. Now you are thinking, what exactly is an ecosite? You can think about it as a small and well-connected community where different actors work together. They operate within the same region and form like a central hub that collects wastewater, biowaste, and non-recyclable waste, all of them generated from both urban and industrial areas. In each ecosite, 2 key technologies are used, an anaerobic reactor and an absorption column. The wastewater and the biowaste are fed into the anaerobic reactor to produce biogas. The biogas can be converted into methane or hydrogen as a renewable energy source. After this step, the advanced ultrafiltration treated membranes separate the sludge and water. And the last one is pumped into the absorption column to produce high-quality water. Finally, the non-recyclable waste is pyrolyzed in a parallel installation, and the char obtained is activated and functionalized with lignin nanoparticles or carbon dots that are sent to the different ecosites to feed the absorption column. By combining all of these steps, each ecosite can produce clean water, renewable energy, and high-value compounds to produce, for instance, fertilizer or polyhydroxyalkanoids that can be reused locally, helping to close the loop. I would like to highlight that the SYMSITES consortium brings together 31 partners from academic institutions, municipalities, and industries, all across 8 European countries and Israel. Now that we have reviewed the 4 ecosites and the pilot system developed across the project, we will move into a set of presentations that explore key technical dimensions in more depth. We will begin with the challenges and opportunities of water reuse, followed by a closer look at scaling the anaerobic bioreactor technologies, and finally, the critical aspects of material sourcing will be discussed, both in terms of separation strategies and the impact of seasonality. That's it from my side.
Thank you very much, Emma. So yeah, you said it all about both the SYMSITES project and what we can expect now from the next presentations. So yeah, I think we can jump right into the 4 EcoSites presentations, starting with the Spanish EcoSite, where yeah, our colleague Jose Antonio will present in the context of yeah, water scarcity and water reuse, which of course in a country like Spain is quite important. So Jose Antonio holds a PhD in chemical engineering, specializing in biotechnology processes for waste valorization, such as anaerobic fermentation. After completing postdoctoral research stays at the University of Tübingen and in France, he joined Nealis innovation team in September 2023. Nealis includes companies such as Vorwasser, a service sector company responsible for transportation and collection of municipal waste within the SYMSITES project. So over to you, Jose.
Thank you very much, Felix, for the introduction. So, well, as you mentioned, I'm going to talk about the water reuse, the challenges and the opportunities that we have. I'm going to jump to the outline of my presentation. So I'm going to talk, well, I will give a brief context of the current problem, a glance to the directives and laws. I'm going to briefly talk also about the results that we are obtaining at the Spanish EcoSite, and I'm going to give a take-home message. So briefly, Europe is right now the fastest warming continent in the world, and already almost 40% of our population is affected by water scarcity. So this means that almost a third of our territory is affected by this problem, and translated into money, this problem costs around 2 to 9 billion per year. So we are already facing it. We reuse approximately 1 billion of cubic meters of water, but our potential is way bigger. We could reuse up to 6 times more. So looking at the map of Europe, we can see that there are regions that are especially affected by this problem, especially the Mediterranean regions. Portugal, Spain, Italy, Malta, Greece, Cyprus, Turkey are the main countries affected. And going to the Valencian community, which is the region where we are implementing the EcoSite, we are already facing this problem. We are one of the highest rates regions in reusing wastewater, but we need to do more. The water that we reuse here mainly goes to agricultural applications, up to 90%. But we also have other uses that we would like to promote by means of new technologies and symbiosis. So here on this slide, you can see a glance to the legal framework of water. As you can notice, there are quite a few laws and regulations at different levels, European, national, and regional levels. So it can get a bit complex, but I want you to focus today on the Royal Decree that is highlighted in red. This is the Royal Decree that we have in Spain for wastewater, for water reuse. So when it comes to this legislation, it is important to highlight that when we transposed into the national laws, the European directives, this can be more restrictive, but not less restrictive, okay? So this Royal Decree envisions different uses for water. We have, for instance, agricultural uses, industrial uses, environmental uses, and urban uses. These are the ones that I'm going to focus today so we can see how this industrial-urban symbiosis could be applied in a region. So here you have a picture of the outlet of water that we obtained after our anaerobic treatment in our EcoSite. And to see the possible uses, we performed a physical-chemical characterization and a microbiological characterization. So you can see that we analyze parameters such as pH, turbidity, the chemical oxygen demand, the total suspended solids, the volatile suspended solids, and that we obtain without treatment a high COD removal up to 94%, which already complies with the directive of urban wastewater treatment. We also analyze microbiological parameters. We analyze pathogens such as E. coli, Clostridium, or total bacteriophage, and the rest that you have there on the table. And you can see that on the outlet water, we obtained a high removal of these pathogens, between 3 and 6 on a logarithmic base. So once we have this this characterization, now we need to have a look to the law to see in which use we can employ this water. So focusing on the urban use, this is what we, when we check the law, this is what we see. We have a table with different parameters, microbiological and physicochemical parameters. And then we have quality of the water, and depending on the values that we obtain for our parameters, our water will fall in one of these categories. So in our case, we can see that the quality that we are obtaining so far in our ecosite is quality B. We have slight higher values in turbidity. The law demands 5, but we have around 19. And then we are almost accomplishing the values for suspended solids. But the rest of them, we fulfill the requirements of the law. So this quality that we are obtaining for the water, this means that we could use this water in an urban symbiosis context for street cleaning, for irrigation of urban areas, for industrial vehicle washing. So these kind of uses are the ones that FOBASA, which is in the consortium, and it is a service-oriented company in charge of the waste collection in cities, and also the street cleaning and the cleaning of green areas. These are the potential uses that the water could have for them. So the take-home message for this presentation would be that in water-scarce regions and in general in Europe, the question shouldn't be if we reuse water or we don't reuse water, but how fast we scale the appropriate technologies to do it. So I'd like to finish by thanking all the consortium, and especially to the partners taking part in the Spanish EcoSite. Thank you very much. And that's all from my side.
Thanks a lot, Jose. So once again, any questions from the audience, please put them in the chat, and we will hear more from Jose also later in our panel discussion. So this very important topic of water scarcity, yeah, it's definitely one we have to keep in mind already now, and as Jose pointed out, also in other regions in the future in Europe. So quite important to keep this in mind. With that being said, I can hand over to our next speaker, Wolfgang Garbauer, who is a senior researcher at the University of Natural Resources and Life Sciences in Vienna, Boku University it is, in the field of biogas research and consulting. He's responsible for managing the Austrian EcoSite. So Wolfgang, over to you.
Thank you for the introduction. Hopefully you can see my slides.
Yes.
We are managing the Austrian EcoSite, and we are handling with wastewater and organic waste from the meat processing industry. In this case, especially for this company, Fleischwaren Bergerschinken. It's a big employer in the region with approximately over 750 employees, and they are producing ham, sausages, and they are producing approximately 650 cubic meters of wastewater per day. And aim in this pilot plant, in this EcoSite, is to provide for them cleaned wastewater for cooling facilities. They need approximately 60 cubic meters per day for their cooling tower. And they want also to realize nearby apartment buildings, and they want to use the excess heat of the biogas production of the CHP to heat these buildings nearby. This is the pilot plant we realized within the SYMSITES project. We decided in this case not to use a membrane bioreactor, but a flotation unit. The wastewater is flotated, so the organics are concentrated in this flotation unit, and the flotation sludge goes to a biogas reactor, which is in this container nearby. The biogas reactor has approximately 3 cubic meters of working volume. And the cleaned wastewater after the flotation unit goes to a further container with a membrane, with ultrafiltration, nanofiltration, and reverse osmosis. And here are some pictures of the pilot plant, yeah. And we are additionally feeding to the biogas reactor not only the flotation sludge, but also additionally the blood from the slaughterhouse, because Bergschinken also has a slaughterhouse additionally to the wastewater use. These are the results after the flotation unit and cleaning with the membranes, with the ultrafiltration, nanofiltration, and reverse osmosis. So there are requirements for the cooling water in the cooling tower. But however, we are reaching every parameter, but not the pH and also not the chloride concentration. The chloride concentration, of course, is important because of the corrosive effects. And we have by far too high chloride concentrations. And this is because of using the main flocculant iron chloride. And we have to reduce the iron chloride or only use polymer in the flotation unit to get rid or to concentrate the organics here. These are so-called the substrates we're using in the biogas plant in the reactor. The wastewater, the parameters of the wastewater, the 650 cubic meters coming out of the company, and we concentrate the organic in the flotation unit. Then we have the flotation sludge going to the biogas reactor, and additionally, we're using the big blood as substrate in the biogas plant. And you can see the, of course, the water content in the blood is by far lower than in the flotation sludge and wastewater, and therefore we have by far the highest biogas potential in the biogas, in the blood, using the blood. But also using blood, you have a lot of proteins and a lot of nitrogen, and so the problem is for the bacteria here ammonia inhibition. So we have to take care to not feed too much blood. So full-scale plant, upscaling. The company Bergschinken is planning now a full-scale plant, full-scale wastewater treatment and biogas production. And there are 5 parameters when companies are planning a biogas plant. The substrate mixture, of course, the substrates going into the biogas digester, the organic loading rate, so how much organics are fed into the digester per cubic meter, the hydraulic retention time of the biogas digesters, how long is the retention time of the substrate in the digester. The nitrogen concentration should not be too low because of the pH buffer in the digester, and not too high because of ammonia inhibition. And a lot of projects do forget the digestate usage, because the digestate is a very valuable fertilizer, but sometimes you have in your region already too much of nitrogen, and you have to get so-called rid of the digestate. And in the internet, you can find a lot of calculators for biogas production methane potentials of different substrates. We calculated the waste streams of Bergschinken, and we calculate that we have a CHP unit with approximately 150 to maximum 200 kilowatt power electric output. And and for the membranes, for the cleaning units, sorry, once again, this is the dimension of the main digester, post digester. Using the volume, organic loading rates, then you can calculate the dimensions and volumes of the digesters. And here's a calculator we provide for companies that you can calculate on the basis of the carbohydrates, protein, and fat, your biogas production amount, and also methane concentration. And this is the membrane part. So you can calculate as company the upscale of your membrane unit using the flux liter per square meter and hour of your membrane. So you can increase the amount of the surface in your wastewater treatment. And within the SYMSITES project, we are planning to use the wastewater and the biogas in the community. There are agricultural uses, for example, using for irrigation, and Bergerschinken is collecting the meat from the nearby farmers. We can use in future the pig manure as fertilizer in the biogas plant, and the digestate will go back to the farmers again. And in the municipality of Sigurtskirchen, they have trees they have to irrigate in future. Hope when it will be from the legal side an option. We can use the clean wastewater, and they use a lot of water for irrigation of the soccer field, for example. And at Bergerschinken, in future, we will use the wastewater, the clean wastewater, for cooling purposes. 40 to 60 cubic meters of cooling water they are using per day. And this, for example, is another example of a biogas plant using slaughterhouse residues in Austria. And aim of the big slaughterhouses is to use all the organic waste. Slaughterhouses have a lot of organic waste to be energy independent in future. A lot of slaughterhouses are planning to build biogas plants. So that was all from my side. If there are questions.
Thank you very much, Wolfgang. Very interesting, and also great to see this. Yeah, I think the biogas technology is nothing new or novel, but something that has been around for a long time, but now applied also in a new context, and yeah, just very applied and with lots of different usages. I think that's a great example of what also this type of project SYMSITES can achieve. Yeah, progress basically. Thanks a lot for that. And yeah, as we mentioned before, and any comments, questions, just in the chat, and then our presenters are happy to reply there. So now we have to improvise a little bit. So you may remember in the beginning I mentioned that we also wanted to do a quick Mentimeter poll with the audience, but since we are running a few minutes behind schedule already, we will just skip that and jump right into the next presentations from our two remaining EcoSites. So we will stay right on topic and learn more from the project. And we will continue to do so with Matthias Kjærgaard, who holds a vocational qualification in gastronomy and later trained as an environmental technologist, complemented by further education in project management, where he now has years of experience working with biowaste across the entire value chain, from sorting to collection to treatment and valorization. And he represents the Danish ecosite on the island of Bornholm and the company BOFA. Over to you, Matthias.
Thank you. And can you see my screen and
Yes.
in presentation mode? Wonderful. Yes, my name is Matthias, and I'm working at BOFA for the waste management company on Bornholm. So we are not the biggest part of running the biogas pilot plant in the EcoSite. We are running the feedstock for the food waste, and that's why we're going to talk about the waste separation, and we're going to talk about stakeholder engagement on Bornholm and the social spin-off part we are going to develop in this project. But first of all, Bornholm is located here in the middle of the Baltic Sea, and that's where the EcoSite is located on the tip of Bornholm. So our closest neighbors is Sweden, Poland, and Germany, and it's also important part of the culture of at Bornholm. We are only living 40,000 people on Bornholm, in small communities on the island. And the Danish EcoSites looks like this. This is Svanike, where it's located, or a little bit outside Svanike. So it's a small city, only living 1,000 people in it. And the symbiosis we was going to create here at the wastewater treatment plant, we were going to have the wastewater from the municipality and from a brewery, the local brewery. And we have the food waste. So we were going to put it through the membranes and make the biogas. And then the plan was to have the biogas back to the brewery, and they could brew new beer on the heat from the biogas. And the wastewater was going to be for irrigation at the local Frannegård, where they can grow all the local barley they need to the brewery. And so that's what the plan with the small symbiosis here. And all our task from BOFA was to bring all the food waste from the city. And we'll get back to that a little bit later, all the issues with the food waste from SMEs and the private households. Our second task from BOFA in this was to create a spin-off from this symbiosis and try to make new symbiosis in the city, but it's quite difficult to make a symbiosis running sustainable in the city. So we was going to extend from a little bit to the rest of the island. But in the circle you have here, it's actually a lot of the SMEs and private households we have in Svanike, with some of them was going to work together for creating the new symbiosis. The green one is some of the SMEs, and you have some of the arrows. It's the waste streams we had in the city. For example, if you start in the corner up right, we have the fall fruit from all the local gardens. We could collect it, and we can make cider or apple juice, and the rest of it we could ferment it, and they could distill at the local distillery. All the restaurants or bookshops or private households, they could collect the coffee grounds if they could keep it clean enough. And then we had a guy called Emil in the city, where he could grow oyster hats, and we could sell them in the local alimentary. So we could manage to create quite a few symbioses, and we are still applying funding for more symbioses. The last one we applied for was in December, where we could use all the rest oil from the used oil from the restaurants and try to make a kiln for the local. We had many ceramics on Bornholm, so we could use the oil local instead of transporting back to the rest of Denmark to have it recycled. So we can use the methanol from the fall fruit distillery, which we can't drink, and mix it with the used oil and have the local kiln running on waste from the rest of it. And the key challenges we met here, the food waste grinder and the quality of input material. We managed to pick up food waste from 5 households and from one restaurant at a time. Then the amount of food waste was enough, so we kept it that way. But it's difficult because it's easier and cheaper from the SMEs, the restaurants, just to throw it in the normal bio bin on Bornholm and get it picked up. So it's a lot more work for them to give it to us. And then we come and collect it for free. The time they spent, the staff spent to sort the waste took a long time, and they need more containers. And then we had issues with the pilot, because every time they had, for example, coffee grounds, the pipes at the pilots clogged, and the same happened when we tried to do it with onion, just normal onions. It was clogging the drum filter, so it was too difficult for us to sort out the food waste, because we need the SMEs to to sow coffee grounds and onion shields in a different bag, and it's not going to happen. So we need to change some thing in this for at least the grinder, but otherwise actually the grinder worked fine. But maybe we need a more a longer period maybe to have an idea of how we should change it. So we also did that to change it. We have a partnership schools on Bornholm where we have education for all the small children in the school, and they're going to visit BOFA and learn about resources, symbiosis, and waste at least 3 times when they're going to the primary school. So we was develop education material for about local symbiosis and resources, so we could get in that way from the children. And we developed a cardboard game in this project, which have been used on most of all of the schools at Bornholm right now, where the kids are allowed to play with the resources and the plan. Not the plan, but when they're playing the game, they can get 1 point, 3 points, or 5 points. It depends how good symbiosis they build in the local society. And the cardboard game looks like this. It's a map on Bornholm where we have we have a little bit bigger than Svanike, so we have the rest of the island as a part of it. So we have all the SMEs, not all, but most of the SMEs on Bornholm, and when we have mapped the waste streams for them, and we have mapped all the places where they can go with the waste. And it's working out good. Thank you. That's all from here now.
Thank you, Matthias. Very interesting presentation as well, and also great to see the social component that we already discussed in the chat earlier in this webinar, also highlighted here again with the great work carried out there. So now we had meat industry, we had beer, so a lot of good consumption, and now of course what we can't skip is some tasty Mediterranean olives. So I'm handing over to Professor Gerasimos Liberatos, who's a professor of chemical engineering at the National Technical University of Athens, specializing in technologies for treatment and valorization of liquid and solid waste streams. And he's the head of the Greek EcoSite and will introduce us to this case. Over to you.
Thank you very much, Felix. Good morning, everyone. The Greek EcoSite is located in the wastewater treatment plant in the municipality of Western Achaia, shown here, close to the city of Patras, which is the 3rd largest city of Greece. Athens is here. This urban industrial symbiosis extends over a larger area of approximately 13.5 square kilometers, and this encompasses the municipality of Western Achaia, an industrial zone where quite a few industries are present, and the wastewater treatment plant. The partners in the project are for the Greek EcoSite are the National Technical University of Athens, the SYMSITES company, which is a developer company of the EcoSite, the municipality of Western Achaia, responsible for the main operation of the wastewater treatment plant, and Eleoργικές Επιχειρήσεις. This is an olive industry located in the industrial zone. The main objective of the Greek EcoSite is to treat industrial and municipal wastewater from the municipality of Western Achaia, along with food waste. The treatment process aims to produce hydrogen, methane in an anaerobic membrane bioreactor, compost and water for irrigation, while we have also looked at the possibility of producing polyhydroxyalkanoates. Here you can see a picture of the wider area and the wastewater treatment plant. And here's a picture of the pilot plant, where you can see there's a buffer tank, there's a main stir tank reactor, which is about 5 cubic meters, and there is a hydrogen-producing reactor, smaller. Let me start by saying that, of course, in a conventional wastewater treatment process, like the one which is in place right now, you can see here the typical scheme in an activated sludge process, which, of course, has a very high energy cost, and large amounts of sludge are being generated. Instead of this conventional wastewater treatment plant, one can use high-rate digestion of municipal wastewater. This could be not very costly process, and there are several alternatives that have been produced and generated in the literature, and also in with some applications like anaerobic filters, a USB reactor, an anaerobic baffled reactor, etc. By using anaerobic digestion as the main treatment technology, you can have significant energy savings, since there is no aeration needed, while biogas is produced and less sludge is generated. The limitation is, of course, that you cannot really generate much biogas if you use the low-strength municipal wastewater. And an alternative to these processes is the use of an anaerobic membrane bioreactor, so that we have, in the first phase of our pilot plant, we've looked at the possibility of using municipal wastewater with this technology. Municipal wastewater is fed in a buffer tank. From there, it's fed to a methanogenic reactor, which has the effluent goes through a membrane module and is recirculated. This way, we can reduce significantly the retention time, and the effluent goes through an absorption column to generate a clean water. What we found was that we were able to get high-quality treatment within discharge specifications with the municipal wastewater. Then, looking at the other possible streams, let me briefly introduce to you the idea of food waste drying. We've used a food waste dryer shredder, which generates two streams. One is what we call food residue biomass. This is the smaller amount, and the bigger amount is condensate, which is quite clean in appearance, but of course has a relatively high organic load. So the idea then is you can use these streams. You can use the condensate along with the olive industry wastewater and the municipal wastewater, and you can use the 4B, the food residue biomass. You can store it because it doesn't have much moisture and it can be maintained for long periods of time. And then you can use it in various ways to produce compost, for example, or to produce hydrogen, as we will see. A problem that we have in our case is the seasonality of olive industry wastewater. Olive industry wastewater basically starts working in October and works until January, maximum February the next year. So, the wastewater that is generated from this is a very high strength wastewater, varying between 100 to 200 grams per liter COD. Now, the idea then is to use three streams. This was the original idea. To use the condensate from the olive industry wastewater when you have it available, and then to use the condensate from drying and shredding the food waste in the other periods, or along with the olive industry wastewater. So here you can see the key characteristics of the three waste streams. And here is perhaps the most interesting final phase, where we have actually used all different sources. You can see here that we've used the dryer shredder to generate 4B, and this we have used to generate hydrogen. Then we have the municipal wastewater, the olive industry wastewater, and the liquid fraction that results from drying and shredding, along with the effluent from the hydrogen producing CSTR reactor. All these are being fed to the buffer tank, and from there to the methanogenic stir tank reactor, where biogas is produced. The effluent, then, we have seen the possibility of using adsorption to remove the pathogens and also the emerging contaminants and come up with clean wastewater. For the adsorption, we used the biochar, which was generated by a partner based on olive stone. So this is quite interesting because olive stone is also a byproduct of the olive industry, and it can be used to generate this biochar. And the biochar may be used for this adsorption column to generate clean water. From the conclusions from treating the effluent with biochar from olive stone, basically the idea there was to use the olive stone to pyrolyze it, and we found that most of the organic carbon is removed, and the concentrations of emerging contaminants are significantly reduced to acceptable levels. Then on the other hand, the 4B, the food residue biomass, the solid fraction from drying and shredding the food waste, could be used, and also olive stone could be used, or a mixture of the three could be used for composting, and we've carried out composting experiments. And here you see a typical evolution of the temperature for a mixture that consists 1/3 roughly of prunings, 1/3 of the olive stone, and 1/3 of 4B, and this generated a very high quality compost. Thus, from the Greek EcoSite, the benefits for the municipality and the industry are outlined here. The municipality can have a cheaper treatment cost, since we will have no cost for aeration and sludge management. We have a compost that may be used in parks. We can have hydrogen to be used as a fuel, water for irrigation, and I should also mention that although not studied at pilot scale, we have been also working in seeing with lab scale experiments the possibility of producing very good polyhydroxyalkanoate bioplastics to replace fossil-based plastics. Now, the benefits for the industry are that basically you have no treatment cost for the wastewater. Biogas following upgrade may be used in the industry, or following biogas upgrading, which we have also studied, you can generate bio-CNG, namely biological origin compacted natural gas, that can be used, as we have demonstrated in another project, that can be used for vehicles. Of course, the industry can use water for washing and or process, and finally, of course, they can use compost, to support the green area around the industry. So this is it from me at this point. And of course, I think later on I can present the main lessons learned and talk about the stakeholders' involvement. Thank you very much.
Perfect. Thanks a lot, Rasmus. Yeah, very, very interesting case as well. I think both the seasonality, but also how basically different streams from the same industry are being applied in the same system are great showcases here in the Greek EcoSite as well. Okay, so now we move to our last big agenda point, which is the panel discussion. So we want to bring the 4 EcoSites back on our virtual stage, let's say, and ask a few follow-up questions on some aspects that were not covered in the rather technical presentation, and also go and look beyond that. And for this, I'm handing over to my colleague, Chiara. Chiara is an expert on circular economy, also working at EcoEurope, where she's the leading expert in industrial-urban symbiosis. And she has worked quite extensively with the EcoSites over the last years in the SYMSITES project, and has prepared some questions for our EcoSites. So over to you, Chiara.
Thank you very much, Felix. Hi, everyone. I will jump right in so we can make use of the time that we have left. So thank you very much to all the speakers for your interesting presentation. Within this presentation, we have learned a lot about different challenges and successes that the EcoSites have along the way, both in technical and non-technical terms. But today is a replication webinar, so I would like to ask all four of you, what are your main learnings in this journey, and that you will share with someone that is looking to start a similar approach in the EcoSite. And perhaps because you were mentioning this, I will start with our last speaker, Erasmus.
Okay, let me share again my screen. Okay, I hope you can see it.
Yes, we can.
Okay, what are the main lessons learned? First of all, anaerobic membrane bioreactors are perfect and economically viable systems for treating municipal wastewater treatment with significant cost savings. Industrial wastewater may be co-treated with municipal wastewater, and this way we can increase the production of biogas that may be used as a fuel or for the production of electricity. Then municipal food waste may be dried and shredded, this way providing a liquid stream, a condensate, that may be effectively co-treated in the anaerobic membrane bioreactor along with other streams, and a solid fraction that may be used for the production of hydrogen or composted along with prunings and or olive stone to produce high quality for compost. The anaerobic membrane bioreactor effluent may be treated with biochar, which is generated from olive stone, and this way you generate water suitable for irrigation. I must say that we obtained an effluent which is class B, but is quite close to being class A, depending on the time, on the contact time and the amount of biochar used. Industrial-Urban Symbiosis reduces the overall treatment cost by producing useful products such as biogas, hydrogen, water, compost, and bioplastics. And this is it.
Perfect. Thank you very much, Gerasimus. And now I hand it over to Matthias for a short summary of your main lessons learned.
Yes, I'll just do it without a slide, Chiara. I think the main lessons we learned that sometimes it can go really slowly when we are trying to create those symbioses or spin-off symbioses, and sometimes it just takes time to get it running. And when it's running, it can run fast. And if you only have started one small symbiosis in a small city, it's maybe easier to get a new symbiosis running. It's our experience. So when you're in doubt, just keep going with it, and it will run fast at some point.
That's a very interesting point, Matthias. Thank you for saying this. So now to Wolfgang for your main lessons learned in the Austrian EcoSite.
Yeah, the main lessons learned, maybe because in the first step in the lab scale reactor, we saw that we had problems with the anaerobic membrane bioreactor. So we decided conventional system in the pilot plant, and the industry is interested. So the meat processing industry needs a lot of energy. They want to produce energy out of the organic waste, and more of them are interested to use the organic waste because of increasing natural gas prices. But often it's a kind of challenge to implement biogas production and wastewater treatment. For using, we have learned within the SYMSITES project, using the cleaned wastewater, not for technical usage, maybe in the cooling tower, it's a technical problem, but using for irrigation and other usages. Not the technical barriers are a problem, but the non-technical barriers, the legal aspects. Are we allowed to use the wastewater for irrigation of the soccer field or other purposes? Are we allowed to irrigate the trees? And that's then, in my opinion, the bigger challenge beside the technical challenges.
That's a very interesting point, Wolfgang. Thanks. We've seen extensively with the various pilots that it's not just about like the technical challenges, but somehow these other non-technical barriers can really pose an issue. So it's really good to clarify this to potential replicators. And now for like the main lessons learned in the Spanish ecosite, Jose, to you.
Thank you. So me and my colleague Raquel, we wonder a lot about this issue. What would we do differently? And I think it is very important at this point to properly map the resources flows that we have, and also to identify also properly the companies or the stakeholders that are involved in the symbiosis, because at the end we are making a treatment, but we need an end user for this product. So it is very important to identify their needs. And also, I think this links to the non-technological barrier that I think it is also very important to take into account since the very beginning, which is the communication. I think it is very important to communicate the treatment and the product that we are obtaining, and to be able to adapt and to be flexible to what the end user needs.
This is a very interesting point. Thank you, Jose. I think it's such a thing that preparing at the beginning of the ecosite can save a lot of like headache, or like a beginning of your project, can save a lot of headache like later on in the process. So because it's such an important point, the one of like engaging the right stakeholders and convincing them. So perhaps Gerasimos, I know that in the Greek ecosite, you've had some experience with that, because like all these ecosites are kind of at a first glance, they're very niche and specific. And so if you can think that they might not be able to attract a broader audience. But in the Greek ecosite, you've organized a lot of stakeholder forums with a variety of stakeholders, including, for instance, children and teachers in schools. So, like, my question is, why do you think that it's important to involve the civil society in the work regarding the ecosite, and how did you manage to do so in your experience?
Thank you, Chiara. Okay, so industrial-urban symbiosis is, of course, not only a technical system, but it's a social system. At the Greek EcoSite, we have multiple waste streams: municipal, industrial, food waste, co-treated, and this will work only if the waste suppliers are reliable and willing, if the authorities allow flexible permitting, and most importantly, if the citizens accept the reuse outputs, irrigation, water, compost, biogas. Without stakeholder buy-in, even a technically perfect system becomes an expensive aquarium. Thus, to this end, we have carried out dissemination activities in schools and the general public. Those are important for raising awareness and securing social acceptance. Dissemination activities with municipality, this is important so that the mutual benefits of IUS are properly understood by the municipality officials and the potential barriers are identified and addressed. Dissemination activities with industries in the region are very important so that they can see and identify the possible opportunities that arise from this symbiosis. And finally, regulatory officials, last but not least, I would say, they are important so that the proper legal framework is developed, and possibly, and most important, is, of course, the possible financing is secured. Thus, we have primary operational stakeholders, the municipality, the olive industry, and other, of course, industries in the region. We have a whole industrial park, as I said. The wastewater treatment plant operators and secondary enabling stakeholders are, of course, the regulatory authorities, the schools and the general public, and regional industries. We have identified some key barriers via special activity and seen how this can be neutralized through involvement. This is where stakeholder involvement becomes a problem-solving tool, not just a checkbox. And typical barriers that were addressed through this engagement were, of course, the fear of using wastewater in agriculture, the uncertainty about co-treating industrial and municipal waste, regulatory hesitation around novel technologies, that have not been proven at full scale yet or used elsewhere. Industrial skepticism about reliability and costs. Through the early and continuous dissemination, these barriers were identified, and before scaling up, it is very important to carry them through and answer all the questions that arise, to discuss using real performance data, and the barriers may be reduced through shared ownership of the outcomes. The transferable insights. Most importantly, stakeholder involvement must start before technology deployment. Public communication is as important as process optimization. Regulatory dialogue enables innovation rather than blocking it. And the symbiosis success depends on trust loops, not linear supply chains. We've carried out a workshop for non-technological barrier assessment. We've done several events with schools, such as the annual SOS primary school shown here. We've done a special workshop on waste sorting in the old town of Lousica in the region. And I will just finish up by saying that, emphasizing that industrial-urban symbiosis only works if society understands that waste is a resource in the wrong place. So thank you very much.
Perfect. Thank you very much, Gerasimos. And it's great to hear like these insights, which I think resonate a lot with what Jose was mentioning before, and also the point that Mariana made earlier in the chat about like early involvement and the people driving this process, which I think is very interesting. And such a case, for instance, was the one of the Danish EcoSite, where there was a strong component of this social spin-off that Matthias has mentioned before. And my question now to you, Matthias, is from your experience in Svaneke with the social spin-off, what do you think that are the elements that are most transferable to other regions that want to build these community-driven circular initiatives? And if you can highlight, for instance, a city or a region that would like to do such a social spin-off, what are the actionable step-by-step process that they should follow?
I think the most important before you start is maybe look what we already have of experience in our situation. For example, in Bofa, we had another project for a couple of years ago where I was going to make this co-design manual we also used in SYMSITES. And we used it in 2 other cities on Bornholm, and it was way easier to get the stakeholders to participate in stakeholder events than it was in SYMSITES. And we actually did the same way with the invitation, and the event was maybe close to the same, where we were going to invite all the citizens in the city and the SMEs in the city to one big event. And it was worked out wonderful in the 2 other cities, but in Svaneke it was quite difficult. We invited 1,000 people for the first stakeholder event, and we only got 4 people showing up, and it was my family, to be honest about that. So before starting, our theory about this is maybe in Svaneke it's more a busy city, even it's a smaller city compared to the other cities. And it's mainly families with the children living there, and then they need to prioritize the time, so they will not participate in sorting food waste for a Horizon project, to be honest. So I think it's maybe the most important part is if we would need to replicate something, maybe we should start in the neighbor city actually to see what worked there and why it's not working here, and then we need to move it out to different cities because I think iOS is moving forward. Also, when it's a remote island, for example, Bornholm, where the resources we have if we don't need to take with the ferry. So maybe you should start looking local, what's working there and why is it working, and make analysis of that. Does it make sense?
That's great. Yeah, absolutely it does. And I think like it's a common thread over a lot of like the points that are being made about starting with the mapping and understanding your local context before proceeding to setting up such exchanges. So this is a very interesting point. And then, I mean, like this already connects to the other question for Wolfgang, because when you started this process, you had very distinct stakeholder configuration, right? Like in your Austrian EcoSite. So for instance, you had the Bergischen and the company, also like a small municipality with the local authorities and the public. All these different stakeholders are different stakes and interests. So of course, there was some conflict there. So if you could tell, for instance, about your experience, like how did the EcoSites pilot came to be and how were these different stakeholders' interests balanced and negotiated?
Maybe in my opinion, one most important output was, we have in our project partner is the owner of the wastewater treatment plant in Sigurtskirchen, the municipality, and also Bergerschinken. And Bergerschinken is by far the most important employer in the region with more than 750 employers. But they are producing a lot of wastewater, and the wastewater treatment plant was struggling to handle this high amounts of organics, and there was a conflict in between the municipality and Bergerschinken. And then we started this project, and it was very interesting because the company, the head of the company, Bergerschinken, they were not communicating with the mayor of the city because they were discussing who is now responsible for treating the wastewater, who is responsible for the next step, investment costs. And then our project started. And my colleague and me, we were sitting in between the head of Bergerschinken and the municipality, the mayor of Sigurtskirchen. And it was very interesting to listen because Bergerschinken did not pay the fee for handling the wastewater, for example. There was a huge amount of money not paid, and and I was sitting in between, and then we discussed about this project, how to handle the wastewater, what are the next steps, what can be improved, and the most important information was with which technology we can remove the organics out of the wastewater, and that the wastewater treatment plant can handle in future the wastewater in a better way, and so that everybody is happy. So we as a university, we were in between somehow and communicated, discussed with them, and they are happy now with the output of the result. And now they are making the next steps.
This is really great. Great to hear. Thank you, Wolfgang. And maybe like you could spend like 1 minute. We have one question in the chat for you that is regarding what is the energy from the biogas plant used for? And if there are like any plans for biogas upgrading, gas grid integration.
Yeah, that's an interesting question because normally in Austria and everywhere in Europe, the way is to upgrade the biogas, feed in the biomethane into the natural gas grid. But for slaughterhouses and also for Bergerschinken, they are using the produced energy on their own. Or Bergerschinken now is planning to build apartments for their employees nearby and to use the excess heat of the CHP for heating the buildings, yeah. And for other projects at slaughterhouses, there's no funding scheme for realizing biogas plants in Austria. There's no possibility that industries in Austria can use their own produced biogas on site. They have to upgrade it, feed it into the natural gas grid and buy it back again. Then they are allowed to get fundings and incentives. Otherwise, they do not get €1 fundings when they use their biogas on site without upgrading, for example. So they have to feed into the natural gas grid nearby and put back again the cleaned biomethane. That's the regulation now. That's also a non-technical barrier which has to overcome. Yeah.
Thank you very much, Wolfgang. Yeah, this is a very interesting point to be made. Sometimes, like, the regulation can be a hindering factor, and also prevent the access to finance and funding,
Yep.
which we know
Yep.
also is another non-technological barrier, unfortunately. Yeah, this is a very interesting point. And talking about like funding and investments and regulation, Jose, in the Spanish ecosite, you look at this kind of non-technological barriers. So in just a couple of minutes, very briefly, why do you think that securing funding is crucial for implementing and upscaling an ecosite? And how did you address this in the Spanish one?
Yes, thank you for the question. So, well, securing funding is crucial for implementing and scaling the ecosite. That's for sure. But I think that in the case of the Spanish ecosite, the challenge goes beyond, as it implies also systemic changes in the way we currently treat wastewater and the organic fraction of municipal solid waste. Currently, we do it by separate, and SYMSITES envisions a joint treatment. So the funding should be also to change these foundationals of the technologies that we use. I think the approach that we follow right now is to see this project as an R&D project, to gain insights about the technology that we are working on, and to show these results to the administrations, which at the end are in charge of, in the case of Spain, for instance, they own the wastewater treatment facilities, and by public tenders, the companies apply to manage these facilities. So in our case, I think it is very nice to show the administrations how the technology works and the results, the technical results that we can obtain by means of this technology. So they know how the technology works, and they could potentially propose this kind of technologies in their tenders. At the end, the investment and the regulation in this case are closely linked because the administrations are the ones involved in making the laws that then we need to accomplish. So these changes in the regulations drive for us the adoption of new technologies, and there it is there where the investments are concentrated. So to demonstrate the technical and environmental feasibility of a technology to an administration help us to attract the funding.
This is a very interesting point. Thanks, because we know like that the public support can be crucial in securing, like stability and the future ecosites, like that they can sustain. So I'm sorry to have to cut this. We're running a little bit short on time, but we already gained some insights in what is upcoming for some of the ecosites in the future. And now I will hand it over to Felix for the wrap up.
Thank you, Chiara, and also many thanks to our presenters and panelists. So very briefly to wrap things up on time, I want to highlight that within the project, we are going to publish very soon what we call a replication guidance package, which basically allows anyone who's interested in replicating anything from SYMSITES, and assuming that you, the audience here today, are joining to this replication webinar, I think you are among our main target audience here. To replicate specific learnings we made. So we already have 2 virtual tours, so short videos of our ecosites on our YouTube channel, with 2 more to follow of the remaining 2 ecosites. So something worth checking out to learn more, to see also a bit of pictures in moving and not just the presentations. So nice addition to today. We have an extensive replication analysis report, the replication potential report. We are also developing training materials on industrial-urban symbiosis, and we are planning another dissemination webinar as well in the next months. So more to come, and of course, always the best place to look for all of this is our project website, where you can of course also find a few public technical deliverables, since a lot of the presentations today were also rather technical, so to follow up there. Then I want to invite our audience to also fill out a quick form, We can also quickly post the link in the chat, and also we'll share it via email afterwards. If you're interested in being informed about these upcoming opportunities, so basically that we know that you're interested specifically, but also if you want to stay in touch, explore any future opportunities together, you can let us know there, and also give us feedback if you are interested. So yeah, open invitation to get in touch with us or stay in touch with us, and give us some indication what you are interested in. And of course, we will also share a follow-up email to this webinar with a link to the recording, so you can look at everything in more detail again, and also receive all the links and the presentations. And of course, if you want to stay informed, one other good way to do so is, of course, the SYMSITES project LinkedIn account as one of the main communication channels. And also we as ICLE are hosting Circular Cities related LinkedIn account, where you will also be informed about a lot of other circular developments. With all of that, I want to thank our speakers, thank also the audience for the engaged discussions in the chat. It's a pity we didn't manage to address everything. I thought very interesting points also being raised in there, but sure, something to keep in mind and to keep discussing on. And I wish all of you a pleasant rest of the week. And once again, many thanks for joining us today.
Thank you.
Thank you. Bye.
Bye.
Thanks, everyone. Bye.
Thank you.
Bye all.